Hi, question number 6. The time in minutes taken by Peter to walk to the shop and buy a newspaper is normally distributed with mean 9.5 and standard deviation 1.3. Find the probability that on a randomly chosen day, Peter takes longer than 10.2 minutes. Okay, for the first part, we have a normal distribution where x is normally distributed with mean 9.5 and standard deviation 1.3. What we need to find is that Peter is going to take longer than 10.2 minutes. Therefore, we need to find P of x being greater than 10.2, which is basically P of z being greater than 10.2 minus the mean mu, 9.5, all over the standard deviation, 1.3. Work that out, you're going to come up with P of z being greater than 0.53846. So what is that? Now what we should realize, it is greater. If you have your bell curve like this and P of z being greater than a, that's going to be basically 1 minus P of z being less than a. Okay, so 1 minus the xi of 0.53846, and that's going to be 1 minus 0.7046. If you check that out from your table, and the answer should be then 0.295. Here we are for the first part of the question. Now for the second part, we need to find, okay, on 90% of the days he takes longer than t minutes, find the value of t. On 90% of the days he takes longer than t minutes. So we're looking at the probability of x being greater than t, longer than t minutes. Therefore that's going to be standardized, and that's going to be z being greater than t minus the mean mu, 9.5, all over the standard deviation, 1.3. And that is going to be 0.9, 90%. Okay, so therefore this is greater. Okay, so if you, alright, so let's take a look here. That's going to be the xi of z being xi of z being greater than t minus 9.5 over 1.3. It's going to give us 0.9. If you look at the inverse of 0.9 from your table, 0.9 is 1.282, but we're looking at the right hand side. Therefore that's going to, sorry, here we are. At the right hand side, that's going to be negative. Okay, so that's going to be then t minus 9.5 over 1.3 is equal to minus 1.282. Therefore t is going to be 1.3 times negative 1.282, and all divided by, no, sorry, this goes on there, multiply, plus, rather, this 9.5 is minus, plus 9.5 there. So it's going to give us, t is going to give us, let's work this out, 1.3 times brackets minus 1.282, okay, plus 9.5, 7.8334. Okay, so t is 7.8334. Let us say t is going to be 7.83 to 3 SF. So this is t, number of days. Now for the third part. So moving on to the third part, we have calculate an estimate of the number of days in a year of 365 days on which Peter takes less than 8.8 minutes to walk to the shop and buy a newspaper. So he's going to take less than 8.8 minutes. So we're looking at probability of x being less than 8.8, which is then, when you standardize, z being less than 8.8 minus the mean mu, which is 9.5, and all divided by the standard deviation, 1.3. Okay, so 8.8 minus 9.5, Okay, so 8.8 minus 9.5 divided by the standard deviation 1.3 minus 0.53846 minus 0.58346 and so on. So I just look at the bell curve. Minus P of Z being less than minus A is exactly the same as 1 minus P of Z being less than A. So we're looking at 1 minus the xi of this, 0.58346 and so on. So 1 minus, then what is 0.53846? So 0.53846, so 9 is 31. So we're looking at this, 0.7019 plus 0.0031. That's going to be 0.705, isn't it? Yeah, 0.705. So therefore, we're looking at 0.705. So 1 minus 0.705 is going to give us 0.295. So 0.295. So for 365 days, that's his probability of walking to the shop to buy a newspaper on any day. Therefore, just hold on. Alright, so that's going to be 0.295 times 365 days. Okay, so times 365 days. It's going to be 107.65 days. So 107.675 days. So we're saying 107 days or maybe 108 days. So these are the number of days that he's going to walk to the shop to buy a newspaper on any year that has got 365 days. Here we are, questions taken from June 2016, Advanced Level Maths HSC S1, question 6.